Hey everybody, welcome to another Con support video. My hair's a little wild at the moment, but hey. We're going to do this one on the Con scale of probability models, so understanding probability models. So it says Michael, Ronald, Linda, or Lydia, Alexandra, and Catherine are sharing a basket of fries. The following table shows an incomplete probability model for who will eat the next fry. What is the probability that Ronald will eat the next fry? So what you guys can see here is Michael is zero point 0.3, Ronald's unknown, Lydia is 0.1, Alexandra is 0.32, and Catherine is 0.1. Well, what we need to do is we got to figure out what percentage is left over, right? Because as you guys know, if these are the 5 people that are sharing this basket of fries, and this is the probability model that represents that, there must be a total of 100% chance that the fry is going to be eaten, right? So it's going to be eaten by someone. These are all 5 people sharing the basket. So basically, we got to figure out what portion of this is remaining for Ronald, right? So take the calculator, and you might need a calculator. Let's see if you got a calculator. There's our calculator, right? Let me just bring that up here. And what you could just do it right here on the calculator. I don't really need the whiteboard space for this one. So you just go 0.3, so okay, 0.3 plus 0.1, 0.1, plus 0.32, 0.32, plus, and then 0.1. All right. And this is the sum of all the other members, right? Michael, Lydia, Alexandra, and Catherine, the other people who are sharing this basket of fries. This is the sum of all their chances. So the chance of them eating the fry is what? 82 hundredths or 82%. So there's an 82% chance that one of those people who we have a known value for will eat this next French fry. But that means that there must be a remaining portion, that's probably Ronald's section, Ronald's chance of eating the French fry. So remember, the total is always 100% or one whole. So you just subtract the 0.82 from one whole, and as you guys can see, that would be 18 hundredths or 18%. So that means that the chance for Ronald to eat the fry would be 18 hundredths. Okay, and then we go to the next one. So on this one here, it says, let's see if I can move this down. It says, Manor randomly selects times to walk into a local restaurant and observe the type of music being played. She found that the restaurant was playing country 11 times, rock and roll 17 times, and blues 8 times. Use the observed frequencies to create a probability model for the type of music the restaurant is playing the next time that Manor walks in. Okay, so we're looking at this situation here, and we're like, all right, well, what's the total number of times that she's observed, or he, I don't know if Manor was a boy or a girl, this person's observed the music. So I would go over to my little notepad over here, and I would say, okay, he's done 11 times that he's witnessed the country music, right? There was 17 that he's witnessed the rock and roll, so we can just call that R&R, right? And there was 8 times that this person witnessed blues, okay? So how many observations were made? Find out the total number of observations. What's 11 plus 17? That's going to be 28. What's 28 plus 8? That's going to be 36. So there are 36 total observations that were made, right? That's the number of observations or the number of times that this person witnessed what was happening there, right? So out of the 36 times, right, based on this experience, this is experimental probability, not theoretical, but experimental probability, right? So we're going to say, based on that previous experience, what's the likelihood that he's going to be witnessing country the next time he comes in? Well, it'll be 11 out of 36. What's the likelihood that it's going to be R&R, rock and roll? 17 out of the 36. And what's the chance it's going to be blues? It'll be 8 out of the 36, right? So that's kind of what you're going to put here. So when you add it all together, that's 36 out of 36, or 100% of what this person witnessed. So the chance of country, 11 out of 36. The chance of rock and roll, 17 out of 36. And the chance of blues, like we said, is 8 out of 36. And there's your answer. It's that simple. For the next one here, it says the sports world is open every day. The sports world is open every day. Chelsea, Ivy, and James are the only employees at Sports World who can open the store. The following graph shows an incomplete probability model for who will open the store on any given day. So this is just like that first problem we had, right, where there's a missing value, and that value has to be the thing that we add to everything else to get to 100%, right? So we can see that based on this particular data, we got Chelsea, right, and Chelsea's got a value of 0.3. So hers is 0.3. We know that Ivy, the other person who can open it, has a value of 0.1. So Ivy does it 10% of the time. Chelsea does it 30% of the time. And so then the question is, well, how often does James do it, right? So if this is the probability model, we know that this is 30% of the time for Chelsea, 10% of the times for Ivy. That's a total of what? 40% of the time so far that's been covered, which means that James must be whatever you add to 0.4 to get to 1, right? Well, what would you add to 0.4 to get to 1? 0.6. In other words, James must do it the remaining 60% of the time. Because together, all three of them have to open the lock or lock up the store. Lock up the store? No, open the store 100% of the time. So it's going to be this value of 0.6. So there you go. So it says here, what's the probability that James will open the store on a given day? A 60% chance. All right, the next one says, a consumer report counted 72 low-quality, 112 medium-quality, and 711 high-quality computers based on a random sample. The report went on to say that all computers, regardless of quality, are packaged identically and sold at the same price. Okay, fair enough. So let's investigate this. It says use the observation frequency or the observed frequency to create a probability model for the quality of the next computer purchase. All right, fine. So there were 72 that were poor quality. There were 112 that were medium quality. And then there was 711 that were of high quality. Fair enough. If you add all that together, you're going to get the total number of computers that were analyzed or checked. That's 2 plus 2 plus 1 is 5, 7 plus 1 plus 1 is 9, and then 1 plus 7 is 8. So there were 895 computers that were checked in all. Okay, this is experimental probability. So based off of those 895 observations, right, how many of the times was it low quality? 72 out of the 895. What was the chance of it being medium quality? 112 out of the 895. And what was the chance of it being high quality? 711 out of what? Out of the 895. And this is the frequency that you have these different types of quality of builds based on the observations made during the experiment. That's it. The next one, Anna, Irina, Avel, and Vlad are going on a road trip. The following table shows an incomplete probability model for who will be driving during any given kilometer. Okay, remember, the sum of these has to add up to 1, right? So when we go look at it, we can just take all the values and add them together, and we should get what's covered so far. And then the remaining portion between that and 1 is the amount for this leftover person. So just taking a look at it, we can see that it says that Anna had 1/8 and that Irina had 3/8 and that Avel was unknown and that Vlad had 1/8. Okay, so if we take those three that we know together and we take those and we add them up together, we're going to get 1/8 plus 3/8, which is 4/8, and then 4/8 plus 1/8, right? So together, these two together add up to your 5/8, right? So that means is that 5/8 have been covered already. So that means that Avel must be the remaining portion, right? So what's 1? 8/8. Take away the part that we already know, 5/8, and you're left with Avel, which would be 3/8. So Avel is going to be 3/8 of the time. So for Avel, you just put 3/8, and you're good to go. And then the next one says, E10 randomly selected volcanoes to travel to and study. After traveling, he had 13 cinder cone volcanoes, 18 shield volcanoes, and 6 stratovolcanoes. Use the observed frequencies to create a probability model for Eaton's randomly selected if he randomly selected one volcano in the world on which to conduct an extensive study. Okay, so basically, if these are all the different volcanoes that he's chosen in the past, and he were to pick something in the future, how can we figure out what that thing he might pick would be? So let me move this over a little bit. There we go, so I can select a new color. And I'm going to go grab black here. Okay, cool. So I think we know that the cinder is going to be 13. And then the shield so far was 18. And then you have the stratovolcanoes, which is 6, right? So we'll just call those strat, and we'll call those 6. So together, what was the total number of volcanoes that he has looked at in the past, that we have evidence that he's looked at? 3 plus 8 is 11, plus 6 is 17, and then 1 plus 1 plus 1, so we got 37. So there's 37 total volcanoes, right? So if we know there's 37 total volcanoes that he's looked at, then what we're going to do is we're just going to put everything out of 37, right? So the chance of him choosing a cinder volcano would be 13 out of the 37. The chance of him choosing the shield would be 18 out of 37. And the chance of him choosing a strat would be 6 out of 37. And together that's 37 37s are all the things that he's chosen in the past. So we just do 13 out of 37, and then 18 out of 37. Then they simplified or changed it. It's fine. Just leave it as is. And 6 out of 37. And that's the answer. Okay, this one says Manny, Rochelle, and Peg race each other in carts. There are no other racers, and exactly one racer wins each race. No ties allowed. Following graph shows an incomplete probability model for who will win the given race. Okay, so basically, Rachel wins all the ones that aren't covered by everybody else. The total of any probability model should be 100%. So you've got Manny right there with 0.35, and you've got Peg with 0.25. So you just got to add those two values together, right? So Manny wins basically 35% of the time, 0.35. And Peg wins how often? Peg wins 25% of the time, right? You can see 0.25 right there. You can see 0.35 right there. So Peg wins 0.25. So together, how often do they win? 35 cents plus 25 cents is going to be 60 cents, or 60% of the time. So they win 60% of the time, which means that the other remaining person in part of this model, Rochelle, must win the remaining portion of the time. Well, what's 1 take away 0.6? 0.4. So that means Rochelle must win 40% of the time, because together it all has to add up to 100%, or one whole. So that means that Rochelle is going to be 0.4, so that's it. And that's how you do those problems. Hope it helps.